Hi there, we're going to do a quick tutorial video on how to do Chapter 1, Lesson 1 in the 8th grade book. We are solving simple equations. Remember, you can pause the video if I go too fast, and you can write all of these down in your notes. Always pause it, or you can fast forward, whatever you need to do. Now, what we're doing in Chapter 1, Section 1 is we are adding and subtracting to get a variable all by itself. Now, I have some tricks to do this. The first one I want you to write down is x minus 7 equals negative 6. What we do is we ask ourselves, what's happening to the variable, okay? What's happening to x? Well, it's being subtracted by 7. So we do the opposite of that to both halves of the equation. So our equation is split in half like this, right? We got some on this side, we got something on this side. If I'm saying x is being taken away by 7, I need to then do the opposite of take away 7, which is to add 7. Now, if you do it to one side, though, of the equation, you have to do it to the other. Okay, now think of this as just one big, long addition problem. Negative 7 plus 7, that equals 0, which means it goes away completely. But that's what we wanted, right? We want to get x all by itself. That's our job. Now x is by itself on this half of the equation. Now I've got negative 6 plus 7. Well, in 7th grade, I taught you some rules. If the signs are different, we subtract. Take the big number minus the little number. 7 minus 6 is 1. We take the sign of the bigger number. 7 is positive, so it's going to be positive 1. Bring down your equal sign, and my answer is x equals 1. We can always plug that back in for x to see if it worked. So put that 1 back here for x. 1 minus 7 equals negative 6. See if it works. 1 take away 7 is the same thing as 7 take away 1, which is 6. Take the sign of the bigger number. The bigger number happens to be negative 7, so it would be negative 6. And we put a check mark to show that it worked. Okay? Let's do another example together. Let's do this one. Y plus 3.4 equals 0.5. My job is to get the variable all by itself. And to do that, we do the opposite of what's happening to it. So y is being added by 3.4. So the opposite of that would be to subtract 3.4. Now if I do it to one side of the equation, I have to do it to the other. One long subtraction problem. 3.4 take away 3.4 is 0. Those cancel out, but that's what we wanted. We want y by itself. So I'll bring down my y. 0.5 minus 3.4. Signs are different because this is positive, right? Signs are different, so we subtract. Take the big number minus the little number. Bring down the decimal, bring down the 2. My answer is 2.9, but before I say that's my final answer, who is the bigger number, 3 or 0? Well, obviously 3 is bigger, and 3 happens to be negative, so my answer is negative 2.9. Okay? So that's basically what we're doing in this section, is we're just trying to get the variable all by itself. Let's look at this one. Gotta be careful here. A lot of kids will say, oh look, there's so many variables. But you guys, pi is not a variable. Pi is a number, okay? So just treat it as if it was any other number. My job is to get the variable all by itself. What is happening to the variable? It's being added by 2 pi. So the opposite of being added by 2 pi is to subtract 2 pi. Keep the 2 and the pi together. It's totally fine. Now, if I do it to one half of the equation, I have to do it to the other. 2 pi, take away 2 pi, that's no more pi. All I have left is h. 3 pi, take away 2 pi. Guys, that's just like saying if I had 3 Skittles and you took away 2 of my Skittles, how many Skittles do I have left? 1 Skittle. Or in this case, 1 pi. Now, if I have 1 pi, writing it like this is kind of redundant, okay? It's like saying I have 1 pi. Okay, that's kind of silly. So what we do as mathematicians is we say h equals and we just put a pi. Because that is 1 pi symbol, right? We don't have to say 1 pi symbol. Kind of redundant. So my answer is just h equals pi. Now it makes sense though if I plug that back in, right? If I put pi back in for h, let's see what it would look like. Pi plus 2 pi makes 3 pi. It works. Okay? Let's go ahead and do some more examples. I'm looking at page 5 in our book. Let's do one with a fraction. That's always a good thing to practice. I know you guys love fractions. T minus 1/4 equals negative 3/4. My job is to get t all by itself. So we do the opposite of what's happening to it. It is being subtracted by 1/4, so I need to add 1/4. But if I do it to one side, I have to do it to the other. Negative 1/4 plus 1/4, that gets you to 0, so we cancel those out. T is now by itself. Negative 3/4 plus 1/4. Now they were so kind to us and they gave us common denominators already. But if we didn't have common denominators, that would be step number 1. Now we can just go ahead and do the math. Signs are different, so we subtract. 3 minus 1 is 2. Keep your denominator. Who's the bigger number? 3 is bigger than 1. 3 happens to be negative, so we're going to keep it negative. We always reduce. 2/4 is the same as 1/2. Keep that negative though. T equals negative 1/2. All right, let's do one where the equation is a little bit backwards. What I've noticed in teaching is that students do not like it when the answer to the equation is on the left and the problem is on the right. But I tell them, you've got to get used to that because in 8th grade math, we eventually do things with slope like this, y equals mx plus b, where your equations are backwards like that, okay? So yes, you do kind of have to get used to it, okay? Just think of this equation as having 2 halves, not one has to be on the other side, okay? So we want to get k by itself. We ask ourselves, what's happening to k? Well, it's being added by 3. The opposite of that would be subtract 3. But if I do it to one side, I've got to do it to the other. 3, take away 3, that's 0. It's gone. K is by itself. That's what we want. Negative 3 minus 3, signs are the same, so we just add. 3 plus 3 is 6. Keep the signs they both have. Negative 6. Simple, right? I do want to show you one thing, though. What happens when, instead of them giving my variable first and then what's happening to it, that's what all of these did. If you look. Variable first, then what's happening. Variable first, then what's happening. Okay? Variable first, then what's happening. Variable first, then what's happening. That's fine. But I need you guys to understand that sometimes the variable doesn't come first. Okay? For example, I'm just going to make up some numbers real quick. I don't know what this will equal. I'm just kind of ballparking here. What if it was negative 2 plus x equals, gosh, I don't know, 20. Okay? My variable didn't come first. And here's where a lot of kids make mistakes. We want to get x by itself, right? So we say we do the opposite of what's happening to x. And a lot of kids say, oh, x is being added by negative 2. So the opposite of adding negative 2 would be to subtract 2 from both sides. But you guys, my job is to get x by itself. Is negative 2 minus 2 0? No, negative 2 minus 2 is negative 4. Did I get x by itself? Not at all. Always double check. X is being added by negative 2. You want to do the opposite of what this is, okay? That is negative 2, so do the opposite, which is to add 2. Now do you see how that would cancel each other out? That's what we want, right? We want x by itself. Negative 2 plus 2 is 0, so it's gone. You can now ignore the plus sign because it's just x. 20 plus 2 is 22. okay? That's something that I have noticed a lot of students make mistakes on, is when the variable doesn't come first, they like to do the opposite of what's happening to it at all times, but they forget that, if there's a negative there, you gotta do the opposite of that. Now that was all just adding and subtracting. Let's talk about multiplying. We still have the same process of we want to get our variable by itself, we gotta do the opposite of what's happening to it, but there are some tricks, okay? This problem is starting out with a fraction being multiplied to the n. Let's start out with something a little more easy to begin with. Let's say 7x equals negative 35. Okay? Do this one first. What's happening to my variable? It's being multiplied by 7. What is the opposite of multiplication? Division. So we divide by 7. Remember, we use a fraction bar to show division in Big Kid Math. Do it to both sides. 7 over 7 is 1 whole. 1x is the same thing as just x. So is x by itself? Yes, that's what we want. Negative 35 divided by 7, that is 5, and we keep the negative because an odd number of negatives in division and multiplication is still a negative. And that's your answer. However, things are a little different when we are using fractions, and that's why I wanted to do that easy one first, because now we're using a fraction. Now technically, you're still going to divide to get that to go away, right? It's being multiplied to the end, so the opposite would be to divide by negative 3/4. Divide by negative 3/4 to both sides, right? Now here's the problem. Negative 3/4 divided by negative 3/4. To solve that, we skip, we flip, we multiply, so it's actually negative 3/4 times negative 4/3, which when you do the math, you'd get 12 over 12, which is just 1 whole. 1 whole, you guys. That's a lot of work to know that those are going to cancel out. And then over here, I would have to do negative 2 divided by negative 3/4. I'd have to turn that into a fraction. I'd have to skip, flip, and multiply. And then I would get 8 over 3. Okay, a lot of work, right? So we have a sneaky little trick so that we don't divide and then have to skip, flip, and multiply and do all that junk. Here's my trick. If you are multiplying a variable to a fraction, instead of dividing it, just right now multiply by the reciprocal. What is the reciprocal of negative 3/4? It's negative 4/3. But if I do it to one side, I have to do it to the other. This is much easier because I know that 3 times 4 is 12, 4 times 3 is 12. These are going to cancel out right now and make a 1. Okay, they're gone. All that's left is n. Now over here, multiplying is so much easier. 2 times 4 is 8. 1 times 3 is 3. I have 2 negatives, so that's going to make a positive. How many 3's can come out of 8 without going over? 2 of them. 2 times 3 is 6, so take away 6 from the top, be 2/3. So my answer is 2 and 2/3. So remember, if you're multiplying by a fraction, instead of dividing that fraction out, just multiply both sides by the reciprocal. So much faster. All right, let's go ahead and do this one. Let me grab my sheet of paper so we're not distracted by all the other hoopla. Pi x equals 3 pi. Where's the variable? Right there. What's happening to the variable? It's being multiplied. What's the opposite of multiplication? Division. So divide by pi to get it away. But if I do it to one side, I've got to do it to the other. 1 pi over 1 pi is the same thing as saying 80 over 80, or 1,000 over 1,000, or 2 over 2. It equals 1. Pi over pi is 1. It's gone. 1 whole. Now I'm just left with my x. 3 pi divided by pi. Guys, that's the same thing as saying pi times pi over pi. If I have a pi over a pi, isn't that the same thing that we just did right here, and that's 1 whole? So wouldn't these two cancel out and make a whole? So I can take my pencil and cross them out and say they equal 1 whole, they're gone. What am I left with? 2 pi's. So we would write it like this. There we go. Now that was all multiplication, right? Let's do a division problem. Division problems are actually easier. Some kids don't understand that, but they are. My job is to get y by itself. What is happening to y? Well, it's being divided by 4. Remember that fraction bar means divide. What's the opposite of division? Multiplication. So let's multiply both sides of the equation by 4. Now I'm going to multiply it by 4 over 1. Okay? You don't have to write this. Eventually you'll get so good you'll just multiply it by 4, cancel them out like that, right? But here's what the math is. You're actually multiplying it by a fraction, right? There's actually a 1 right here by the y. 4 times 1 is 4. 4 times 1 is 4. 4/4 is the same thing as 1 whole. That's why those cancel out, okay? Now you know the y, like how it works. So now let's just do it the fast way by multiplying by 4. Goodbye. Multiply the other side by 4. Got y by itself. -7 times 4 is -28. And that's my answer. The rest of these are multiplication problems. We can do this one. Let me grab my sheet of paper and hide all this stuff down here. What is happening to my variable? It's being multiplied by 9/100. The opposite of being multiplied is division, so we're going to divide by 0.09, but you got to do it to both sides. These ones cancel out, they make a 1 whole, so I'm left with a w. Now I've got 1.8 divided by 0.09. Now guys, here's a huge tip. You can't have decimals in the denominator. You can't. So the best way to do decimals in the denominator is to kick them out of there. I want to move this decimal over till it's a whole number. 1, 2. It took 2 jumps to make this 9, okay? But if I do it to the bottom, I've got to do it to the top. It took 2 jumps down here, so I'll do 2 jumps up there. Add a 0 where my jump is. Now I have 180 divided by 9, okay? Now this is much easier. Ignore the 0 for a second. What is 18 divided by 9? 2, because 9 and 9 is 18, right? Now add that 0 back in. 20. So 180 divided by 9 is 20. W equals 20. All right, guys, that is just the quick version of how to do 1.1. In class, we will go over all of these examples together so that you guys feel very confident in how to do these. Remember, we multiplied, we divided, we subtracted, we added. There's a lot of work in this one section.